Good morning, guys. Today we are going to learn about something called the combined gas law, which I'm sure you can guess combines all the gas laws that we've learned before. Here's the equation we're going to use. P1V1 over N1T1 equals P2V2 over N2T2. So we've seen PV and T before. N is kind of new for us. N is just the number of moles. So keep that in mind when we're working these. Some notes that you need to remember: your temperature, if it's given to you in Celsius, has to be converted into Kelvin. Don't skip that step. You convert to Kelvin by adding 273 to your Celsius. If you see the term STP, that means standard temperature and pressure, which is always going to mean the standard temperature is this number, 273 Kelvin. The standard pressure is always 1 atmosphere. One other thing to note is that if you have one of these 4 variables that isn't mentioned in your problem or that stays the same before and after, you can exclude it from the formula. So if it isn't mentioned or it stays the same, we can exclude it from the formula. So we're going to work 3 practice problems together before I unleash you on the homework problems. The first one says 150 milliliters of a gas is collected at 27 degrees Celsius and 1.55 atmospheres. What would be the final temperature in Kelvin if the volume decreases to 125 milliliters and the pressure increases to 1.7 atmospheres? So I know y'all are all thrilled with all those words and all those numbers, but we're going to break it down just like we always do, and we're going to make a list of our variables. So the first thing I see is 150 milliliters of a gas. Milliliters is volume, so that then is going to be my V1, is 150 milliliters. It says we collect it at 27 degrees C, so that's going to be my T1. However, red flags should be going off. It cannot be in Celsius, it has to be in Kelvin. So to convert that, all we do is add 273 to that number, which will get you 300 Kelvin. So make sure you use that number. So it says we're at 1.55 atmospheres. Atmosphere is a pressure unit. So that's going to be my P1 is 1.55 atmospheres. Then it says what would be the final temperature in Kelvin. So I'm looking for my T2 then. If the volume decreases to 125 milliliters, so my V2 goes down to 125 milliliters, and my pressure goes up to 1.7 atmospheres. So my P2 is 1.7 atmospheres. So it's really handy before you move on if you can assign all of these numbers to your variable, and then we'll plug it in. So I'm going to just rewrite this down here and then we'll play with it. So I know I'm going to use P1V1 over N1T1 equals P2V2 over N2T2. However, before you move on, check to make sure you actually need all these variables. So we definitely had pressure going on, we have temperature, and we have volume, but I don't see anything about moles in this problem. And up here I said if you don't see anything about a variable, then we can get rid of it. So I'm going to just boop moles right out, make our life easier, and then we'll plug in numbers. So I'm going to plug in my P1, we said was 1.55 atmospheres. My V1 was 150 milliliters over my T1 is 300 Kelvin. Plug in the other side, so P2 was 1.7 atmospheres. V2 was 125 milliliters. And T2 is what I'm looking for. Okay, so at this point you can solve it like we've been solving it by just doing all the algebra and rearranging. However, I realized that life can be so much easier if we just cross multiply. So sorry I didn't do that for y'all before, but I'm doing it now and it'll make your life a lot easier. So what we're going to do is we're going to cross multiply diagonally and combine them onto the same side. So what I mean by that is I'm going to take these guys, this diagonal, we're going to multiply them all together and put them on the left side of the equation, like this. So I'm going to combine 300K. I'm going to multiply it by these guys. So I'm going to do times 1.7 atmospheres times 125 milliliters. We're going to set that equal to the product of the other diagonal. So these guys here. So on that side, I've got my T2 times 1.55 atmospheres times 150 milliliters. So that's how we set it up. That's called cross multiplying, or sometimes it's called the butterfly method, and it will make your life a lot easier. However, if you liked the way we were doing it before, carry on and keep doing that. I think this is a lot easier. The next thing I would do here is combine these numbers. So on the left, I'm going to just go ahead and plug in 300 times 1.7 times 125, which is going to get me the number 63,750. I'm going to do the same thing on the other side. So I'm going to multiply 1.55 times 150, which is going to get T2 times these two multiplied together gets you 232.5. Now all we have to do to isolate T2 and solve this thing is just divide both sides by 232. So I'm going to divide over here by 232.5 to get rid of it. And I'm going to divide over here by 232.5. Sorry, it's a little crushed down there. So when I do that, now all I have to do is 63,750 divided by 232.5, which is going to get me T2 of 274 Kelvin. Okay, on to the next example. So number 2 says a container holding 4.35 liters of gas is at STP. I'm not going to read this whole thing. Obviously, it's a lot of words. We're just going to start assigning things to variables. Say nobody got time for that. So it says we have 4.35 liters of a gas. So liters is volume, so that is my V1. 4.35 liters of a gas is at STP. So if we look back up here, I said STP is standard temperature and pressure, which always means my temperature is always 273 and the pressure is 1 atmosphere. So from just that word STP, you got to come up with the fact that the temperature then is the standard temperature. So T1, my standard temperature is always 273 Kelvin. And my standard pressure, my P1, is always 1 atmosphere. So that's just from STP. And it says it's holding 5 moles of a gas. So moles is my N, and 1 equals 5 moles. Then it says what's the resulting new temperature? So we want to come up with our T2. So what is T2? When we add 3.5 more moles are added. Okay, so that's not saying that my N2 is 3.5 moles. It's saying my N2, we're adding more moles. So I'm going to take my N1, which was 5 moles, plus we're adding 3.5 more to get an N2 of 8.5 moles. So be careful with this wording. If it says you're adding more moles, you're just adding it to the N1. So my 5 moles plus 3.5 more gets me 8.5 moles. That's my N2. And it says we're increasing the pressure to a final pressure of 5.25 atmospheres. So P2, 5.25 atmospheres. And my container is expanding to a new volume of 5.8 liters. So V2 equals 5.8 liters. That is a lot of variables. Okay, so let's go ahead and bring down our equation, which is P1V1 over N1T1 equals P2V2 over N2T2. Let's see if we can eliminate anything. I see we have pressure, we have volume, we have temperature, and we have moles. So we got to do the whole shebang here. We can't just bloop out one of these. So we're going to start plugging things in. I see that my P1 is 1 atmosphere. My V1 is 4.35 liters. Divide that by my N1, which was 5 moles. And my T1 was 273 Kelvin. On the other side, my P2 is 5.25 atmospheres. My V2 was 5.8 liters. My N2, we added them together to get 8.5 moles. And my T2 is what I'm looking for. That's a lot. Okay, so at this point, this is what we're going to cross multiply. So I'm going to take all of these guys on this diagonal, and we're going to multiply them all together. So I'm going to come up with 5 moles times 273K, multiply it by these guys, so times 5.25 atmospheres times 5.8 liters. All that goes on the left. On the right is my other diagonal, these here, which is going to be my 1 atmosphere times 4.35 liters times 8.5 mole times T2. So at this point, again, I would combine all these terms. So I'm going to do 5 times 273 times 5.25 times 5.8, which is going to get you a really big number. 4156.4.25. It's a big old number. I'm going to do the same thing on the other side. So I'm going to do 1 times 4.35 times 8.5, which is going to get you 36.975 times our T2. And now we just isolate T2 by dividing both sides by this guy, by 36 times 0.975. So that gets rid of it on the right. 36.975. So when we do that, this number, this big number, divided by 36.975 should get you a T2 of 1,125 Kelvin. So that one was a lot. That's a worst case scenario problem. We had to use all the variables and do lots of multiplying. So that's the worst case scenario. Let's look at the last one. The last one says a bag has 5.1 moles of oxygen. So that's going to be my N1. 5.1 moles of oxygen. With a volume of 2.4 liters. So my V1 is 2.4 liters. If 40 more grams of oxygen are added to the container. Okay, pause. Let's talk about this. I don't see any grams in this equation, right? All I see is moles. So guess what? You're going to have to convert grams into moles, but don't freak out because you know how to do that. I taught you how to do that. Okay, so to convert grams into moles, just like we did back in February with stoichiometry, we're going to use the molar mass. So I'm going to kind of do a little aside here. We're going to convert G to moles, which we know how to do. So I want to know then how many moles, X mole, of oxygen is equal to 40 grams of oxygen. So we've seen this before. Y'all thought it would go away forever, but it's here now. So to convert grams to moles, I'm going to use the molar mass. Okay, so I know when I set this up, in order to cancel out my grams, grams has to go on bottom. And what I want, moles, will go on top. So to calculate this, we know how to do this. So your molar mass of oxygen, you're going to take the number of atoms in your oxygen, right? So I've got 2 oxygen atoms. You multiply it by the atomic mass of oxygen from the periodic table. So if you don't have your periodic table at home, you can always Google one. But the mass of oxygen is 16. So 2 times 16 will give me a molar mass of 32 grams per mole. We're just going to plug that number in, 32 grams per 1 mole. So I've canceled out grams. I'm left with moles. So all we do then is 40 divided by 32, which is going to get you 1.25 moles. Okay, so if you get this far, you'll be like, oh yeah, Miss K, that's my N2. I did it. Okay, go back and read the problem because the problem's a real jerk. It's saying if you're adding 40 more grams. Okay, so this isn't your N2. You have to add together your N1 plus 1.25 more moles. So I'm just going to write this up here. So up here, my N2 then is going to be my original moles, 5.1 moles, plus 1.25 more moles. So be really careful. So my N2 is actually 6.35 moles. Okay, so we've accounted for this 40 grams of O2. It says blah, blah. We add that to the container. What is the new volume of the bag? So we want to know then V2, what's the new volume? It says assume temperature and pressure remains constant. What that means is I don't have to worry about them in the equation. So if we pull down the original equation, P1 V1 over N1 T1 equals P2 V2 over N2 T2. What they're saying is your temperature don't change and your pressure doesn't change, so you can get rid of them. So we can just get rid of temperature and get rid of pressure and make our life so much easier. So we can rewrite that as just V1 over N1 equals V2 over N2. This equation right here is actually another gas law of its own called Avogadro's law. But we just kind of incorporate it into the combined gas law, and we don't really do a separate lesson on it. So now we just plug in. So my V1 then was 2.4 liters. N1 was 5.1 moles. My V2 is what we're looking for. And my N2 was what we went through all that pain for, which was 6.35 moles. Okay, now we can cross multiply, or you can solve it normally. That's up to you. Since I've been cross multiplying, I'm just going to keep on doing that. So I'm going to multiply these two together and put them on the left. So 2.4 liters times 6.35 moles on the left. And then on the right will be the other diagonal. So we'll have 5.1 mole times V2. Then to solve for V2, all we have to do is get rid of this 5.1 moles. Then when you go do all that math, so we're going to do 2.4 times 6.35 divided by 5.1. It should get you a V2 of about 2.99 liters. Okay, so now you should be prepared to go try some on your own. So go on and work the homework problems. If you have any trouble, please reach out to me, and good luck.